case, welcome Alex Mackey, and thank you for being part of NDC Melbourne.
Thanks very much, Lars.
Oh, you're welcome. So you're going to talk about rockets, or?
We're not going to be talking about rockets. Well, maybe we will a little bit.
Very good. Now, I know you're going to be talking about digital twins, because that's what it says in the title. This is one of the things that I haven't actually played with, so I'm kind of keen to see what the possibilities are. I know it's IoT, and I know that it's that sort of world of things on Azure, but other than that, I have no idea.
Yeah, now for those of you planning to use this to go and stretch around and take a break, please stick around. I'll tell you why I think this is going to be interesting and applicable to a lot of people. It is one of those sort of maybe niche services that's a little bit rarer, but let me tell you all about it. So welcome to Introduction to Digital Twins and the Azure Digital Twin platform. My name is Alex Mackey. Everything I'm going to show you today, I'll put up at my website, simpleisbest.co.uk, so you can go and get this stuff later. I work as a tech lead for an organization called Willow. At Willow, we're very much focused on digital twins and for the building systems and critical infrastructure. So if I do my job correctly, what are you going to learn in the next 45 minutes or so? Well, we're going to start off by talking what exactly is a digital twin in the first place? How are digital twins being used in the real world? Where did these things come from in the first place? And then we're going to look at the fundamentals of the Azure Digital Twin platform, so you can go and implement this stuff yourself. So before you nip off for lunch, one thing I do want to mention is that the global twin market is massive. Now, those crazy analysts, and some of them are a bit crazy, have estimated this is an area that's going to be growing to $17.4 billion by 2024. I think because of the size of this, there's a reasonable likelihood that if you're a developer or involved in some aspect of software engineering, at some point you might quite likely will touch a digital twin project. So what exactly is a digital twin anyway? Well, simply put, a digital twin can be thought of as a virtual representation of a real world item or process. Let's take a simple example. We've got a cog, and this cog is equipped with a number of sensors. Maybe they measure the revolutions of this cog, and they send this data into some kind of digital twin system or platform. And on this platform, we create a virtual representation of this cog. Now, linking these two things, you'll find in the literature, this is referred to as a thread, which I think is kind of a nice analogy, given these two things are inextricably linked. Now, an important thing I want to get across is you don't necessarily need to use digital twins to model things like cogs or engineering or engines, which is often a lot of examples you see. These could be processes as well. And I'm going to show you a few examples of how this has been employed at the moment. Let's start off with a simple example of a digital twin. Now, let's take any typical large building. This building has several, probably 100 different systems operating inside of it. It's got electricity, it's got water, it's got heating, there's various security systems, all sorts of things going on there. We'll take one of these. Pretty much every building will be, or hopefully will be equipped with some kind of air conditioning unit on the top there. Now, this air conditioning unit could have a number of sensors on it. And this sensor is providing various different details. And on a typical one, we might be able to pull out maybe the temperature, the humidity, the air quality, fan RPMs, maybe even when this unit was last serviced. Now, this data could all be fed into another system where the building manager could see what's going on with this air conditioning unit. What temperatures is it at the moment? When was the last time it's been inspected, and so on. Now, when I started working with digital twins, one of the first questions I had were, are digital twins just a form of dashboard? Well, I think there's more to it than that, and let me tell you more. So with all of these type of devices, there's an enormous amount of data they could be giving us, and it's almost too much to do anything useful with. There could be data from literally hundreds or thousands of different sources in a typical large building. And one of the things that I think digital twins enable us to do is to go and take this data. We'll go and process it, blend it, get all the good stuff out, and then we can start drawing insights which we can actually do something with, rather than actually just dealing with a large blob of data that's no good for anyone. Krishna et al. That et al. Just means there's a number of other people involved in this study. I don't know how they decide who's the main one. I like to think they fight it out, Highlander style. Divides digital twins into 3 different types. He talks about digital models or simulations, and that's where data is exchanged manually. Maybe, so for example, maybe in COVID, we're getting some stats each day. Someone's taking those stats and then plugging them into a model. And that's a manual process. Then we have digital shadows, which are one-way data exchange. So the real-world item is sending data into the platform. And finally, the most complex and mature digital twin, where we have bidirectional data exchange. So perhaps in our aircon example, then we have the ability to go and control this aircon unit from our digital twin. Now, typical digital twins will give you 4 main functions. They'll allow you to visualize the current state of the item or process. How hot's this room right now? What's the air conditioning unit operating at? They'll probably trigger alerts under certain conditions. Is that room getting too hot? Is it cooking everyone inside? It will probably allow you to review historical data. Maybe how hot was this room last year at this time and year? And the more advanced digital twins will allow you to simulate different scenarios. And there's even examples of people creating digital twins prior to creating the actual physical product. This can save a lot of money and time in product development. Summarizing the benefits of digital twins, I think digital twins can help you make better decisions. They can assist with maintenance and safety. They can reduce the costs of several things. They can improve efficiencies in your organization. Maybe your building, you shut off different lights and rooms if they're not in use. And of course, making prediction. And I'm going to show you some examples of this very shortly. Now, our product, one of our products is focused on the real estate market. And I want to show you a few key aspects of this. Now, this isn't going to play so well over a stream. So I encourage you, if you just look up willowinc.com, you'll find this on our homepage. But I do want to show a couple of key aspects to it. So we create complete models of these buildings down to very fine levels of detail. And what this enables you to do, the building manager can look at these models. They can zoom into them down to the level of individual pipes and units and see where the problems are. We've got another product associated with rail, and what we're seeing here is some details of some rail track there, allowing the people managing these systems to quickly find issues. But where did digital twins come from in the first place? Does anyone know what this is? It's a bit of a grainy image, but some of you folks probably are familiar with what this image is already. Now, this image here is of Apollo 13. I think even if you're not that interested into space, a lot of people were probably aware of the somewhat ill-fated Apollo 13 mission. So, and apparently this was due to a technician, originally due to a technician carrying a oxygen cylinder and accidentally dropping it, which would lead to a number of events, and eventually one of these oxygen cylinders exploding. Apollo 13 had some problems. And the problem with this was that obviously Apollo 13 is really, really far away from those down on Earth who can go and help Apollo 13. Now, one of the unique things about this was that prior to this mission, NASA had set up 15 different simulators of Apollo 13 and the lunar module. Apparently, there was 4 computers alone needed in order to simulate the rocket system. Now, what was unique about these simulators, and I'm not going to claim a simulator as a digital twin, they're definitely not, is that these simulators allowed the controllers to specify various parameters in order to set the state of the system. And they could set these things up very quickly. So by taking the real world state of what's actually happening to Apollo 13, some of those details they'd have on hand, and some of them they might need to query from the crew, they were able to create a very accurate replica of what Apollo 13 was, allowing them to test various scenarios in order to help get these astronauts back to work. Back to Earth. And I think this is probably one of the first examples of what could be considered a digital twin. Going forwards, we have this guy, David Galentia. I'm probably pronouncing your name wrong. He did a lot of work in parallel computing and the Linda language. But what we're interested in is a book he wrote called Mirror Worlds. Now, bear in mind, this is in 1991. And I'm going to read the second paragraph of this. And he says, "This mirror world you are looking at is fed by a steady rush of new data pouring in through cables. it is infiltrated by your own software creatures doing your business. And David kind of puts forward this idea of digital twins that we have today. We have John Vickers, who is widely credited for being the first person to coin the term digital twin. And depending on the source you look at, this is in 2002 or 2010. But what we really find is it's this guy, Michael Greaves, who goes and popularizes this concept. Now, Michael's interested in how he can apply digital twins to the manufacturing process. And he proposes that we could create this digital construct that's linked to the physical item, and that this could create a lot of efficiencies, allowing us to test various proposals. But of course, digital twins wouldn't have been popular without several other advances. So we see all sorts of things from the proliferation of cheap IoT devices, because if it's expensive to implement these kind of things, then that's a bit discouraging to actually do it. And of course, these things are dependent on various things, such as processing improvements, comms advances, even batteries, because if your devices are running out all the time, then that's no good to anyone. And then we see a heap of other things, protocol standards, cloud hosting systems to go and process this data, down to 3D modeling, VR, augmented reality, and so on. I think you'd even argue recently that our least favorite coronavirus is probably also accelerating some of the work here. A great example, again, I'd encourage you to go to the link here. I'm going to pick out a couple of key points, is a digital twin that's been created of the state of Victoria. Now, this digital twin kind of focuses on a couple of aspects. It focuses on planning aspects, so they believe this is going to assist get various building planning applications through a lot quicker. They look at integrating energy sources into it, and also for disaster planning. So you'll see how they go and use flooding data in order to look at how what might happen to this location had a flood occur. So I'm just going to play that and pick out a couple of points. So it's pretty cool, some of the stuff that's going on with this. Singapore, there's been a digital Singapore since 2014. If you go look it up, there's an immense amount of details in that model. They use it for urban planning and also, again, for disaster planning and modeling. Some recent examples. These digital twins have been employed in order to optimize vaccination centers, in order to get people through as quick as possible, but also in a safe, socially distanced way. We see it used across nuclear power, solar car energy, and even in livestock farming. Now, this livestock farming is particularly interesting in that the people who put this paper together, they propose using facial recognition technology on cows in order to understand how the cow's going at the moment and contribute to that animal's welfare. So it's quite a creative use of some of these things, and you can see there's a lot of different examples here. Some of these things are quite abstract in nature. They're more concepts rather than a physical device that we're mirroring here. So hopefully I've convinced you that maybe this is an interesting area, and it's got a widespread use of examples of where you could deploy this. And what I want to talk about next is how you can go about creating digital twins yourself and using the Azure Digital Twins platform. Now, I also think it's fairly unique service to Azure, and I haven't come across anything similar that's going to offer some of the stuff I'll show you in a minute. Before we get into that, however, Azure offers another service called IoT Hub. Now, a lot of you will be familiar with this service. You can certainly use this with Azure Digital Twins if you want to, but don't feel that you have to. These are independent things. And somewhat confusingly, IoT Hub has this concept of device twins. This is a completely different concept to digital twins. And in IoT Hub world, device twins, it's all to do with config and firmware management. So let's imagine we're setting out to create a new digital twin project. Maybe we want to do something similar to our building example that we talked about earlier on. We've got lots of devices in our building. We're getting measurements from various different places. What do we need? Well, at the start of it, you can think of, well, we're going to need a few things in order to create a digital twin of this building. One of the first things we're going to need is the ability to go and actually define a digital twin. We're going to need to define, what is this air conditioning unit? What are its capabilities? What measurements can we get from it? Also, how are these things related? So maybe there's some kind of plumbing system. It's going to be pretty useful if you know which pipe's connected to which pipe, and this feeds into this component here, and so on. We're going to need a way to go and update the twin state, because if it's not reasonably up to date, well, it's not that useful. We'll probably want the ability to be able to perform different queries across the digital twins that we've set up. So for example, we might want to know which air conditioning units are operating above 30 degrees, because that's really quite hot and we should go and check that out. We're going to want a way of securely integrating with these things. And ideally, maybe you've got investment in the Azure platform already. It'd be great if it's integrated with a lot of existing Azure services. So that brings us to Azure Digital Twin. Now, Microsoft Marketing say that Azure Digital Twin is an Internet of Things platform that enables you to create a digital representation of real-world things, places, businesses, and processes and people. But what does that actually mean? Well, I think we can divide the Azure Digital Twin platform into 5, maybe 5.5 main things. Now, underlying all of this is a graph database. And this is going to store your twin models, the state of your twins, how they're related. But we're going to need a way of defining them. And this is where Twin Schema, or DTDL, comes in. Now, Twin Schema, or DTDL, is the equivalent of creating some empty tables in the relational database world. We've created our tables, we've said how they're related, we've specified our fields and their types, but we haven't actually created any definitions of twins. So we're going to need a way of doing that. And that's where the twin definitions come in. Now, if you want to work with any of this, the Azure Digital Twin platform, and I'm going to call that ADT now, because that's kind of a mouthful, Azure Digital Twin platform, is we've got this REST API that we can work with. So this means whatever language or platform you work with, you can work with this platform. But of course, it's not that convenient to go and hand code all of these things ourselves. So Microsoft also offer a number of SDKs. So we have .NET, Go, Python, Java, JavaScript, and you can also perform some of the operations I'll show you through the Azure CLI. Let's go and create some digital twins. But prior to that, let's have an obligatory warning, the demo code. Now, what I'm going to show you today is not a good way to actually model your twins, and I'll tell you why shortly. It's done because it's simple. Now, in our scenario, let's take a typical digital twin. We've got a house, and this house is using electricity. And we want to know which houses are using more electricity. So how are we going to do this? Well, the first thing we're going to need to do is actually come up with a way to go and describe our digital twins. So let's come out the slides and look at how we go and do this. Now, the way that you actually come up and define your digital twins is using a language called DTDL, which is formatted as JSON. Now, what I've got here is my definition of my house object here. And you can see the type of this is something called a interface. Now, interface is equivalent to a class in programming terminology. And it has a number of different types of fields within it. So there's only a few of them that you're going to need to be aware of. We're going to look at properties, and these are data fields that hold the state of our entity. These are equivalent to classes fields, and there's relationships which link these classes or interfaces together. In our example, perhaps we go to a deeper level of detail and our house has rooms, and a relationship is going to allow you to define the rooms within the house. There's also two other types of property, which I'm not going to cover today, called telemetry and component. Just be aware they're there. Now, our example wouldn't be too interesting on its own, so we're going to build that up. So we're going to say we've got a house that's got an address property, and this house also has a consumption of electricity, which we'll define as electricity kilowatt hours. I've no idea if that's a realistic measurement. I'm not an electrician. And we're also going to create another interface called street, and street has houses. So a street could have 0 or more houses, if you will. And finally, we're going to have a district, and a district has streets. Let's look at how to go and actually define this in our DTTL there. So the topmost thing that we need to care about is this ID property here, and this specifies the name of the class there, and this needs to be unique. This has a couple of parts to it. You can see this NDC bit here. You can think of this as kind of a namespace. It needs to be prefixed with DTMI prior to that. We then have the name of the object, in this case house, that's kind of equivalent to class name, and then we have this number here. Now this is the version of the model that we're operating here. So in ADT I can have multiple versions of the same thing at the same time if I want to. And then house has a couple of properties. We have our street, we have this new property here called relationship, and we've basically declared the name of the relationship here, and we've also told it what type of objects it's pointing at. The other item I just want to call out is this display name here. Now this is used by some of the tools I'm going to show you in a second, and can make it a bit easier to actually go and see what's going on with your ADT models there. Now this is a very simple set of models, and once you start getting into a few more, it's quite easy to go and make a typo or mistake. So Microsoft provide a tool called the DTTL validator, which will actually go and take all your files and go and tell you whether something's wrong with them. So I've created a bat file which just goes and kicks this off, passing in the directory, and I'm going to run that there, and you can see I get this output here that it's gone and validated my free files, and everything's looking good. If I was to make a mistake, say we'll change the type there to interface 2, that's probably going to be enough to pick up, hey, look, something's not quite right there. There's a bit of an issue there. You might want to take a look at it. So I'd highly recommend you use this tool, as it's going to save you a lot of time later. Let's put that back because that's going to cause us trouble later. So we'll run the validator again. All our files look good. Okay, we're ready to go and load these into ADT. So I'm going to bring up the browser here, and what this is here is this is the Azure Digital Twins Explorer, and you can get to this. There's a little button in Azure. You can click it, open Digital Twins Explorer, and you'll get this screen here. And you can see at the moment there's nothing in our Digital Twins graph. Now the first thing we need to do is go and upload our models. So I'm going to click that upload button there, and you can see here's our free files that I was showing you earlier, and we're going to go and load those in. So I'm going to go and select all of those. We'll go and open those. It will chug away a bit, and all being well, over on the left there, we'll then have these items loaded in, and we can see we've got our district, our house, and so on. I have the ability to go and create a twin from the UI here. I can go and click this this button here, and I can go and look at the information on the model, and I can have a quick check what's going on. Now, let's say I wanted to make a change to some of this stuff. We talked about this version number. I could declare version number 2 of the house there, and I could go back, and then I could go and upload that if I wanted to, and you'll see that we now have 2 house, and we can see that's the second version there. That's going to get a bit confusing, so let's go and get rid of that one. Now, at this point, we've uploaded our structure here. We've kind of got empty tables in database terminology, and we actually need to go and create our twin graph. Now, like everything in ADT, there's a number of different ways to go and do this. The way I'm going to go and do this is I'm going to go and upload an Excel file. Now, this Excel file needs to be in quite a specific format, and Microsoft specify the column order and structure of this. So what we have here, we have our model ID that corresponds to our class name. We have the ID property. Now, this is the unique name of that particular digital twin instance there. So you can see we've created several different houses there. So we've got house 0 to 7. We've got 3 streets, 2 districts, and so on. Now, you can also set some initial data to define the state of these digital twin items here. So I'm just going to give it a simple numeric address there, and we'll initialize electricity kilowatts to 0. We'll set some street names and district names. Let's get rid of that. Now, once you're ready with that, the way to actually upload it, I go and click this upload arrow there. I'm going to go and upload this twin setup there. And then we get this preview here of what it's actually going to create. Now, this isn't created until I go and click this save button there to start import. So I'm going to go and click that start import there. And all being well, that's going to load in everything into our digital twin graph there. And we can see we've had 13 twins imported and 11 relationship imported there. Now, you might be thinking that's going to get kind of unmanageable once you've got a very large number of items. And I think you're right. And I'd actually, unless you're doing some initial experimentation, I would discourage this way of doing things. The other disadvantage of uploading stuff through the UI is it really doesn't give you very many error messages. So whilst I was putting this, when I was putting this example together, you literally get something like digital twin could not be created, which isn't really very helpful in order to understand what it is that you've done wrong. So ADT offers several different ways to actually update and create your digital twins. You can use the Azure CLI. You could use one of the SDKs. My preference, I'd encourage you to use one of the SDKs, and you're also likely to run into a scenario where you'll start to get dependency issues. So you need to create certain things before, say, you need to create the house type before creating the relationship of a street has houses. So that will give you that fine-grained control you need in order to set up and go and create your twin graph. So that's my recommendation there, but it's great for playing around for small examples like this. So we've imported our graph here, and you can see we've got this structure here. That's the structure that I showed you on the slide earlier. We have a district, and a district is made up of streets, and streets have houses in them. Now, if I go over to the twin graph, I'm not seeing anything here at the moment. And that's because I haven't run this query bit here. Now, I'm going to go back to the query stuff in just a minute. There's something a bit more I want to talk to you about with models. So we've defined our models and relationships, and we've now got everything set up. Now, you might be asking, it could take a bit of time to go and create some of these models, and especially once you get into a more complex domain. Like, imagine you're trying to model a smart city or a whole building. That's going to take a lot of time to go and create these models, and also go and get the modeling around it right. It's not easy. This is a fairly early days for how best to model these things. There's not a lot of there are best practices, but we're still working out, what some of those things are. So one thing you can do is you can look at ontologies. Now, ontologies are a collection of models for a specific domain. And there's already some examples of many different domains. So there's an example for a power grid system already. There's an example for smart cities, all sorts of things. So you could go and take one of these models, and that's going to save you a lot of time from going and creating one of these things yourself. And also potentially a lot of error, as hopefully someone's worked out some of the issues, and the approach they've proposed is going to work well for a lot of people. Now, Microsoft put forward there's 3 main strategies for using these models. You could potentially adopt them entirely. Maybe you convert them and you just take the bits you want. Maybe you go and extend them. But all in all, this can save you a lot of development time when you're working with these type of things. So I'd highly encourage you, if you're coming to a new digital twin product, go have a look what's out there first, because there's probably something that you can at least base your work on before you set about creating your own models. We've actually got our own building-based one, which is an extension of some of the smart cities work there. You can go and find that on the public GitHub there, and you'll see just how detailed and how complex some of these models can get. Here's a visualization of the smart cities one on the Azure repo there. So probably your next question is, okay, so we've got everything set up there. We've defined our instances of digital twins. How do we go about actually updating these things? Well, again, you've got several different options in. You, of course, have the various REST APIs and SDKs. There's some integration with Logic Apps at the moment. And then we have IoT Hub as well. Now, I put an asterisk next to IoT Hub, as you do have to do a bit of work yourself. You can trigger an event which creates a function, which I'm going to show you an example of in a minute. but you do still need to do a bit of programming yourself, so it's not completely plug and play. In terms of getting data out of it, of course, you could create some polling mechanism via the REST APIs, SDKs, but you also have a number of different other options. There's out-of-the-box integration with Event Hub, Grid, Service Bus. You can make use of events for various things occurring, from tweeting created, relationships changing, telemetry being received, and so on. Let me show you a simple example of how to integrate this from .NET. So I've got an application here, and the first thing you need to do is go and specify your digital twin endpoint. Now, I'm going to use the default Azure credentials to connect to this in my example, because it's a little bit simpler. Now, these are created when you go and log into Azure through something like the Azure CLI, and they save a bit of work, and also means I don't have to hide credentials while showing this to various people. So I've already logged into my subscription via the Azure CLI, so that's authenticating to this. Now, of course, in the real world, you're not going to do that. And you have two main options with ADT for authentication. If you've got something already running on the Azure platform, you're going to want to use managed identities. And here you basically find out, you tell Azure Digital Twins, hey, I want this Azure function that I've just created to be part of this role in this ADT graph and have these permissions. It sounds complicated. It's actually not. There's a couple of commands you have to run. I'll show you in a minute. But that enables ADT to authenticate that your service should have access and authorize the actions that they're taking on it. Now, if you've got something external, it supports the standard OAuth protocols. You'll need to set up an application in Azure AD and so on. Again, there's detailed instructions on how to go about setting this up. So back to our simple example, I've got a simple .NET Core CLI program here, and we want to go and update the electricity usage of house 0. How do we do that? Well, we go and create a new JSON patch document with this line here. I'm going to set the electricity usage to 22 kilowatt hours, however much that is. And then I'm going to apply this to this property here, electricity kilowatts hours. And we, I don't know if you remember, we declared that property at the top level here. So we can see the name of that. So that's mapping through to that property there. And then we're just going to write out that it's successfully updated this value. So all being well, we'll go and run that up, and hopefully that will connect. And then when we go and look at the graph again, we should see that 22 in the value. All done, so that all looks good. We'll go over to Azure Digital Twins Explorer there. Now, I'm not seeing any digital twins right now. We'll go and run the query there, and let's go and get our twin graph. There's all the twin items that we've created there. I could go down and manually go and select house 0 there. And we can see by selecting this, I can see the properties over on the right here, and I can see that the electricity kilowatt hours has been updated to 22 here. Now, it's exactly the same approach if you want to go and update this through an Azure function, for example. So going to a more complicated example, and this is based on some of the example code in the documentation, but I've cut it down a little bit to make it a little bit more simpler. What we're going to do is we're going to have a .NET application, and that's going to send in some random values to Azure IoT Hub here. Now, when these values appear on the hub, we're going to raise an event which is going to go and trigger. We've got this Azure function that's listening out for. And this Azure function is going to use some very similar code to what I've just shown you in order to go and connect to Azure Digital Twins graph and update the state of this item there. And of course, we could then write a .NET application, website, API, whatever it is, to go and read out the state of this graph. Now, there is one more step we need to do, and that's that security step that I mentioned earlier. So we're going to use managed identities, and we're going to say we want this Azure function to have an identity, and we then want to put the identity and associate that with the Azure Digital Twins data owner role there. That's going to give it quite a high level of permissions there. So you probably want to get a bit more granular, but it's going to enable us to go and update that twin graph there. So just to show that working there, I have my simple program which is just a console application. And this application here is just going to send in some random values into the IoT hub. It's triggering that event, which is triggering the function's picking up, and then it's going updating the state of our house. So all being well, we should see this value change. I'll click off it. We'll go and click on it again, let me close that one down, and we should hopefully see that value updating over time, so we can see it's changing there as these events are received and update the state of the twin there. Now, one thing I should mention is it will only hold the state of the last value updated. So you're going to need to, if you want every single value of the history, you're going to need to implement that yourself. And it does kind of make sense when you think about the immense amount of data that could be sent and stored on this item, that you're probably going to want some control and to choose how you go and store and what you do with this data. So at this point, we've got everything flowing into our graph, but how do we go about actually getting data out of it? Well, again, we have a number of different options. Azure Digital Twin supports a SQL-like query language. Now, it's not SQL, so there's some things there's many things you can do in SQL, which you can't do in ADT world, but some of the basic sort of SQL-like statements, it supports. There's also some new keywords and digital twin specific functions that have been introduced to make your life easier. And again, you can use this through the REST API, SDKs, and so on. So what do the queries look like? Well, you've got your standard SQL ones where we might do select star from digital twins, and where we might specify a where clause. I can go out of this and we could go select star from digital twins, where address 1 equals 10, and then hit the run query. I can also click this overlay results one, which is kind of an interesting thing. So that kind of filters out the other stuff and shows you where the results of your query sit there. So that might be quite nice for some sort of visualization there. So you can see it's quite easy to go and work with this graph there. So going back, there's a couple of more complex things or functions that ADT enables you can do. You can check where specific properties are defined, whether there are specific types, whether there are models. And of course, because this is a graph database, we can perform some more complicated things. So for example, if we wanted to only select houses within an individual street, we have the ability to do that. Now, it's probably fair to say that it's not as feature rich as some graph databases, at least right now. So, but it certainly enables you to walk some of these relationships that you've set up and defined here. So in our scenario here, if we might want to select, see what's going on in a particular district, but only see the houses within that. Now, you can certainly do that for a relational database, but I think it's maybe a bit more intuitive, and it also enables you to do some types of queries that would be quite difficult in standard SQL once you start having nodes linked together and wanting to walk those nodes and their path. In terms of running costs, it's very, very cheap. Obviously, this starts to add up if you add on 100,000 devices sending in data multiple times a second. So you'll want to do some cost modeling around this. But right now, in terms of AUD, I think this entire demo, which I've been playing with for a number of weeks, I've spent $1.20 or something, and I've sent it a heap of data. So it's not one of those services you need to be a bit scared of to play with. It's very, very cheap to run and play with. Now, you might be wondering, when should you go and use ADT? Well, I think it's probably best used when you've got a large number of digital twins to manage. If you've only got 10 items, it's probably more complexity than you care about. Maybe you've got very complex relationships between these items. Perhaps you'd benefit from flexible schema. It's a bit of a pain when you've got that standard relational database to have to, go and manage various fields, change the schema, and so on. And Willow, the ability to change this schema, add to it, it's very expressive. That certainly saved us a lot of development time, and it's been very useful. Perhaps you want to make use of one of these existing ontologies that are out there. Again, I really can't stress this enough. This can save you a lot of pain and development time. So if you are working on these projects, please take a look at what these existing ontologies can give you. As it's a graph database, we can perform more complex graph queries. And so that can be pretty useful. working on a project at the moment where we have a process for modeling, and it's enabled us to jump between the different nodes in the process, move horizontally, move laterally into how these systems are grouped. And this would have been quite difficult, some of these types of queries with your standard databases. And of course, if you've got an existing investment in the Azure platform, it integrates quite nicely with many Azure services. Now, in terms of challenges, there's a few things I just want to raise. I think a lot of people come to IoT and digital twin, and they look at it and they think, hey, this is just taking in a load of data, processing it and doing something with it. And I must admit, I did too. And it's a very naive approach, and you will very quickly find out that's not the case. So when you're working with these types of projects, you have to deal with all sorts of things like the inherent unreliability of these devices and sensors. You'll find data won't be transmitted at the times you're expecting. The batteries will run out. People will vandalize your devices. There's all sorts of different problems to work with here. In terms of digital twins, depending on your use case, it's quite important that your digital twin is an accurate reflection of what's happening in the real physical world. And of course, there's a delay from sending this data, processing it, and reflecting it in your digital representation. And that's going to be something that you're going to have to deal with. So you're going to need to be able to digest that data very quickly. It can be hard and expensive to add these digital version to an existing system or implementation. And it's probably worth noting that some of the things that these are employed in as well will very likely outlive the software that you write. And that's kind of unusual. So hopefully we'd expect a building to last maybe at least 50, 100, probably more years. I can't think of many software examples where that's been around that length of time. The modeling of these things is difficult and it's evolving. I think you can mitigate that to some extent by working with ontologies. Interoperability and standards still developing, especially in the IoT world. There's a number of pain points there. And of course, if you're creating a digital representation of something, you also need to look at the privacy and confidentiality aspects of that, as it could reveal quite a lot of information about people and systems. Wrapping things up, digital twins are a virtual representation of a real-world object or process. They bring together data in an easy-to-understand and actionable form. I think they offer several advantages around making better decisions, analysis, monitoring diagnostics, efficiency, and ultimately the ability to even make predictions. The Azure Digital Twins platform consists of a number of components: a graph database, a language for describing the twins, APIs and SDKs. And if you take one thing away from this, whilst you could implement all this stuff yourself, I really think if ADT can save you a lot of time and pain from doing this. Finally, quick plug for my company. If this world of digital twins sounds interesting to you, we're looking for a number of folks. Please reach out to me if you've got any questions. Tell them I sent you. And in terms of further reading, there's a great summary on an academic article here if you want to get more into the history of it. If you're wondering how our platform works and want to take a deep dive into the architecture of that, please consult this link here. And we've got a great session with Microsoft, and some of my Willow colleagues will explain in detail some of the projects and how we've implemented this. Thank you very much.
That's awesome, Alex. Phew. Well, there is a question, and it's asked by this amazing guy called Lars Clint. There was actually no question because there was so much information in this session, and I have like one main question. I think is sort of like, holy moly, where do I even start? Like, is there a simple example where you can sort of just go?
Yeah,
is there like a setup thing you can play with?
If this looks of interest to you and you want to have a play with it, maybe you've got a Raspberry Pi and some IoT devices in your house, so you want to play with it. What I do first of all is I'd head over to the Microsoft Azure Digital Twin site. There's extensive documentation. It's well written. There's multiple examples. Some of the examples I've showed you there are based on some of the Microsoft stuff. It's really very easy to get started with and play with this stuff.
So you can use a Raspberry Pi.
Oh, absolutely. Like if you want to integrate anything into this, you'll have to write code to either send it into ADT World, or maybe you send it via Azure IoT Hub. And then you'll have to write the bits that link those two things together. But sure, you could update the graph directly.
Code. So that's cool. Wow, that was a lot of information. I like the graphical part of it. appeals to me. It's not all code, right? You can see what's actually going on. So that's
It does,
really
and it does this cool animation where it goes and arranges your
yeah.
graph as well. And especially
Exactly.
on a more complex setup, like my example is fairly trivial. I think there's 10
Sure.
or so items there. Once you get
Yeah.
into hundreds or thousands, you get kind of this spectacular graph, and it's quite easy to sort of navigate between these things.
That's awesome. Well, thank you so much, Alex, for being part of NDC Melbourne.
Thank you.
That was very informative. And if you want to know more about this, reach out to Alex directly or put it in the YouTube chat or wherever else you can find him. So.